Hey there, welcome. Thank you for being here. Go ahead and get yourself ready with a notebook. Grab a pencil or a pen. Whatever you choose to write with is fine. This is math from the void. Math coming at you pretty much out of nowhere. And today we have an SAT style problem from the topic of geometry. Yeah, we're talking about triangles today. As usual, if you want to attempt this problem, give it a read. You can pause the video, take about 2 minutes or so. This one has a bit of busy work involved, so take about 2 minutes. Try to solve it for yourself. And then when you're ready to see how it's done here, you can unpause the video and check me out, fam. Okay, so without further ado, let's read the problem. For this triangle, ABC, we're given some side lengths, AB, BC, AC, and we're asked to find the values for x, if any, don't you love that will guarantee that this triangle is a right triangle. That is very important. Now, of course, we always have a longest side of a right triangle. That's called the hypotenuse. And based on the expressions I gave you here, these ones are pretty easy to work with. In order to tell which side is the longest, it's pretty clear that x plus 5 has to be the longest side, because x plus 5 will be greater than x plus 4, and it'll also be greater than x plus 1. So we can comfortably say that if this is a right triangle, it's really the theme of the whole problem. We're kind of like assuming this. We're going to assume that that's true, and then we're going to check it. And that's a great way for determining if something is possible, right? You assume it's true and make sure that it doesn't, have any contradictions or violate reality in some way. So we're going to assume, then check. And if we assume that this is a right triangle, x plus 5 must be the hypotenuse length. Then we can label the other two sides however you want. If you want to call this one the x plus 1, that's fine. And this would be x plus 4. Now we need to find the values for x that would make this true. And yeah, you can plug in some values and, plug and chug, and maybe you'll get some nice values that work out. But how do we check it for sure? I don't think you would be able to find the values to plug in just by trying to do it mentally, but maybe you'd surprise me. Well, if we assume the triangle is a right triangle, then that means the Pythagorean Theorem is true, because the Pythagorean Theorem is true for any right triangle. So if we can check to make sure that the results of the Pythagorean Theorem is a true statement, then we can guarantee this is a right triangle. And then maybe somehow we can find some values for x. So we're going to have x plus 1 squared plus x plus 4 squared equals x plus 5 squared. We're checking to see what would make this true. We don't know that it's true yet, but we are assuming that it's true for now. Now that we have this equation with x in it, we can try to solve the equation, right? So let's expand these. Simple expansion here, and another very simple expansion. And this is going to be equals to x squared plus 10x plus 25. Great chance to practice FOIL multiplication. If you're not comfortable with perfect square trinomial, get familiar with it. That way this can take, 5 seconds to complete the step instead of taking like a whole minute to complete this step. Combine the like terms, and you'll notice that we have 10x on both sides actually. So we're going to be able to cancel that. Here we clearly have a quadratic equation, so we're going to want to move stuff over. Let's subtract the x squared from both sides. Let's subtract the 10x, which is really nice because it cancels perfectly on both sides. And then since we have x terms on the left, let's go ahead and subtract the 17 from both sides, leaving us with x squared equals 8. Funny enough. So this equation would suggest that x could be positive or negative square root of 8 if you'd like, you can call that plus or minus 2 square root of 2. But we have to do a reality check. Remember, we have to assume that this is true, but then we have to check to make sure it doesn't violate reality. Well, if one of the side lengths is x plus 1, we can't have negative 2 root 2 plus 1 as a side length. This is negative. We cannot have a negative side length. So, as it turns out, we're not going to use the negative solution. We're only going to use the positive solution, 2 square root of 2. If x equals 2 square root of 2, then the Pythagorean theorem will be true for this right triangle, which kind of verifies, right, that it's a right triangle. Okay, really quick there, really quick. We used a little bit of Pythagorean theorem, and we had to use this idea of assuming what they tell us is true and then checking our solutions to that equation. I think that's enough blab out of me. I'll see you guys next time.